Hey there, and welcome. So, picture this. You're deep into a movie, right at the climax, or maybe you're on a super important video call, and then it happens. The dreaded spinning circle of doom. We have all been there. Today, we're going to figure out what's really going on and demystify why our internet, which we pay good money for, sometimes just decides to buffer.
It's the question we all ask, right? You sign up for a plan that promises these insane speeds, but then your actual experience can feel like you're back on an old dial-up modem. Well, in this explainer, we're going to diagnose the problem, look at what's happening behind the screen, and unpack this all-too-common frustration.
All right, let's get right into it. To even begin to understand the problem, we first need to know how to talk about it. We need to learn the language of network performance. So we're going to start by looking at the vital signs, the key ways performance is measured in the first place. And to make sure we get this right, we're going to lean on some amazing course materials covering computer networks and internet protocols, all developed by the brilliant minds at the Indian Institute of Technology, Kharagpur. This will really help us get to the core of the subject. Okay, so if you want to understand why your internet feels slow, you have to get a handle on these four fundamental metrics: bandwidth, delay, jitter, and loss. Think of these as the four vital signs of your network's health. Understanding them is the key to figuring out almost any network issue. So let's go ahead and break these down one by one. Each one of them tells a really critical part of the story about your internet connection, and they all work together to create the experience you have online. First up is bandwidth. This is the big one you always hear about in internet ads, megabits per second, right? The best way to think about it is like a highway. Your bandwidth is how many lanes that highway has. The more lanes you have, the more cars, or data, can travel at the exact same time. This pipe analogy is another fantastic way to see it in your mind's eye. Your total bandwidth is just the width of that pipe. And here's the catch. If you're streaming a 4K movie, playing an online game, and downloading a big update all at once, well, all that data has to try and squeeze through that same pipe. And, this quote from Tim Green just nails it. Sometimes the problem isn't some super complex technical glitch. You're just asking your connection to handle more data than it was ever designed for. For things that use a ton of data, like high-def video, often the simplest fix is just getting a bigger pipe, more bandwidth. Okay, next up is delay, and you might also hear people call this latency. So if bandwidth is how much data can move at once, delay is how long it takes for a single piece of that data to get from point A to point B. Let's use a pizza delivery analogy. Delay is the total time from the second you click order to the moment that pizza shows up at your door. Now, this travel time isn't just about physical distance. It's everything combined. The time it takes for routers along the way to process the data, the time it spends waiting in line behind other data, and of course, the time it takes to literally cross oceans and continents through fiber optic cables. For online gaming, low delay is everything. High delay or high latency is the reason you get that frustrating feeling where you swear you were shot before the other player even came around the corner. That's latency. All right, now for a really, really important one that most people don't think about, jitter. Let's go back to our pizza delivery. Imagine one pizza arrives in 20 minutes flat. Awesome. But the next one takes 45 minutes, and the one after that takes 30. That unpredictable, inconsistent arrival time? That's jitter. Jitter is the absolute enemy of real-time communication like video calls. See, your computer is expecting the data for that call to arrive in a nice, steady, predictable stream. When those packets arrive all over the place, some fast, some slow, your call starts to stutter and audio sounds all robotic and broken. Your device is working overtime trying to smooth out those bumpy arrivals, and often it just can't keep up. And that brings us to our last metric, loss, or what's often called packet loss. To finish our pizza story, this is when part of your order, or yikes, the entire pizza, just never shows up. The data packet gets dropped somewhere on its journey and poof, it's gone.
So what happens when a packet gets lost? Well, your computer has to realize it's missing, then send a message all the way back to the source saying, "Hey, I never got that piece," and then wait for the source to send it all over again. This whole process is called retransmission, and it causes huge slowdowns. It's exactly like calling the pizza place and saying your order never came, and then having to wait all over again for them to cook and send a new one.
So, what's the one big bad villain that causes high delay, high jitter, and packet loss, often all at the same time? Well, the number one culprit is a single phenomenon, congestion. And you can think of it in the simplest terms. It's a digital traffic jam.
It's basically rush hour on the data highway. There are too many people, all trying to use the same part of the network at the same time, and the routers just get overwhelmed. When that happens, our four metrics go crazy. Packets get stuck in traffic, which increases delay. The traffic jams are unpredictable, which increases jitter, and eventually, the routers get so swamped that they have no choice but to just start dropping packets, and that causes loss. So how do we fight these digital traffic jams? Well, network engineers have come up with two main strategies. You can think of it as one being reactive, it deals with the traffic jam after it's already happened, and the other is proactive. It tries to stop the jam from ever happening in the first place.
On the reactive side, you have something called congestion control. This is a key feature of TCP, the protocol that manages most of the internet's data flow. It's like your car's GPS. It sees you're in a massive traffic jam, and only then does it start trying to find you a different route. When TCP senses that packets are getting lost, it assumes there's congestion and automatically slows down how fast it's sending data. It reacts to the problem.
But the proactive approach is congestion avoidance. This is a function of the network itself. Now, instead of a GPS that just reacts, think of this as a citywide smart traffic light system. It's constantly watching the flow of traffic and adjusting traffic light timings on the fly to keep everything moving smoothly. The goal is to prevent the jam before it can even start. It's a much more intelligent, forward-thinking strategy. And this whole proactive mindset leads us to this really big idea that ties it all together. A brilliant system for managing traffic called quality of service, or QoS for short. You can think of QoS as one of the ultimate tools for congestion avoidance. So how does this magic work? Let's go back to our big internet pipe. What QoS does is act like a super smart traffic cop that divides that main pipe into dedicated virtual lanes. It looks at all the different types of traffic you've got going, your video call, your online game, your emails, your downloads, and it gives priority to the stuff that's the most sensitive to delays. So, who gets the express lane? Well, QoS splits traffic into two main types. First, there's what engineers call inelastic traffic. Think of your Zoom call or your game of Fortnite. It's inelastic because you can't really stretch or delay it without ruining the experience. Then there's elastic traffic. This is your email or a big file download. It can be stretched out. It really doesn't matter if it takes 5 seconds or 15 seconds. QoS is smart enough to put that elastic traffic in the regular lanes, which keeps the express lane clear for the important stuff that needs it most. Okay, so we've covered a lot of the core theory behind what makes your internet tick. Now, let's make this all a bit more real and see how we can apply these ideas to solve an actual problem. It's time to put our new knowledge to the test. So here's a pretty typical problem. We have a packet of data that's 1 megabyte in size, and we want to send it over a network connection that has a bandwidth of 16 megabits per second. The question is asking for the transmission delay. All that means is, how long will it take for the sender to physically push all the bits of that packet out onto the wire?
Let's walk through this solution step by step. Now the first, and I mean the absolute most important step, is to make sure our units match. Did you spot it? The packet size is in megabytes with a capital B, but the bandwidth is in megabits with a lowercase b. This is a classic trick question. Since there are 8 bits in every byte, our first step is to convert 1 megabyte into 8 megabits. Now that our units match, the formula is simple. Delay equals the packet size divided by the bandwidth. So we just plug in the numbers. 8 megabits divided by 16 megabits per second, and when you do the math, you get our final answer, 0.5 seconds. That's it. That's the pure transmission delay. It's the amount of time it would take that 16 Mbps connection just to push that specific amount of data out the door. By understanding these basic definitions, you can start to calculate and solve these real-world network problems. So, the next time your video starts to buffer, you can be a network detective. Is it a bandwidth problem? Is my pipe just too small for this 4K stream? Or maybe it's congestion happening miles away, causing really high jitter and making my video call all choppy. The point is, you now have the language to understand your digital world just a little bit better. Thanks for tuning in.